All right, so I didn't post these until yesterday. Not a big deal if you're just getting them, but or if you haven't printed them yet. But this is just a little explanation on each thing about objects in motion. Okay, so obviously the first one is position. Position is usually uh, denoted by x of t or s of t. S of t when we don't have the name of the function, um, and it just determines where you're located. Okay, and an example of the units would be feet or inches or wherever. Okay, the next one is velocity, which is v of t, which is also x prime of t or s prime of t. It's the derivative of position. Okay, it determines how fast the position is changing at time t, as well as the direction of the movement. Okay, so if the particle is moving, I say particle, if the object is moving horizontally, negative means we're going to the left, and positive means we're going to the right. And if we're going vertically, negative means we're going down, and positive means we're going up. Okay. The next one is speed. Speed, which is the absolute, oh, real quick, a unit for velocity would be something like miles per hour or feet per second. Okay. Speed, which also would have the same units as velocity, because all speed is the absolute value of velocity. Velocity can be positive or negative. Speed can only be positive. Okay. It determines how fast the position is changing at time t without direction. Okay. This is important. We haven't really talked about this. You may have seen this in physics, but speed is increasing, and we're going to start getting into that today, when velocity and acceleration have the same sign. Okay. It's not they're both positive, it's that they have the same sign. If they're both negative, speed is still increasing, it's just increasing in a negative direction. Okay. Speed is decreasing when velocity and acceleration have opposite signs. Doesn't matter which one's positive or negative, they just have to be opposite. And the last one is acceleration. Acceleration is the derivative of velocity or the second derivative of position. Okay. Its units would be, for example, feet per second squared. Okay. And it determines how fast the velocity is changing. So it's a rate of a rate. Velocity is the rate of position. Acceleration is the rate of velocity or the rate of position. Okay, this first one, there are no other notes. So if you were looking for other notes to print, there are no other notes. I'm just going to be going through number one with you on the homework, and then you guys will finish up. All right, so number one says a particle is moving along a horizontal line. So we're going left to right, and its position is defined by this function where t is in seconds. Obviously, that's important. And s is in feet. Okay. It says S. It should say this. Change this right here to S of t. All right. Okay, so we got S of t there. Okay. What are the particles' velocity and acceleration functions? So we're just finding derivatives. So we're going to say v of t is equal to, the derivative of this is 6t squared plus 6t minus 36. And a of t, which is our acceleration function, is going to be the derivative of velocity, which is 12t plus 6. All right, question B. What are the position, velocity, and acceleration of the particle at time t equals 1 second? So it's asking us to find x of, or let's say s, sorry, we changed that to s, s of 1, v of 1, and a of 1, which is just simply plugging a 1 into each one of your functions. So position is going to be 2 times 1 cubed plus 3 times 1 squared minus 36 times 1 plus 40. Okay, go ahead and work that out real quick. And you should end up with, what is that? 2 plus 3 is 5. 5 minus 36 is negative 31. Plus 40 is 9 feet. All right, V of 1 is 6 times 1 squared plus 6 times 1. Give me 1 second here, guys. Oh, I think we're good. Oh, wrong button. Okay. And what was this? Minus 36. Sorry about that, guys. And we work that out and we get negative 24 feet per second. And then the last one, A sub 1, is 12 times 1 plus 6, which is going to be 18 feet per second squared. All right, question C, is the particle moving to the left or is it moving to the right at t equals 1? Okay, so if you go back to the piece of paper at the beginning, okay, it tells you we are moving to the left when velocity is negative and we're moving to the right when velocity is positive, okay? Well, at time t equals 1, velocity is negative. So we're going to justify first by saying v of 1 is less than 0, okay, meaning we're negative. So therefore, to the left. All right, question D, is the speed of the particle increasing or decreasing at time t equals 3? Okay, well, time t equals 3 means we got to find, remember, speed is increasing or decreasing when acceleration and velocity have the same sign. So we're going to find v of 3. Okay, and so v of 3 is plugging a 3 into our velocity function, 6 times 3 squared plus 6 times 3 minus 36. And that's 9 times 6 is 54 plus 18 minus 36. What is that? 72 minus 36, which is 36. And A of 3 is 12 times 3 plus 6, which is 42. And since, what did I write here? This is supposed to be 36. 36 and 42 are both positive. So we are going to say that the speed is increasing because V of 3 and A of 3 have the same sign. And we showed our work right here to justify the actual signs. All right, question E, when is the particle at rest? Okay, so that's when the position is not changing, okay? The velocity determines how the position is changing at time t. Well, when the position is not changing, the particle is at rest, so it's when velocity is equal to 0. So our justification here is v of t equals 0. So we're going to take our velocity function, 6t squared plus 6t minus 36, and set that equal to 0. All right, we can obviously factor out a 6 and get t squared plus t minus 6 equals 0, and that makes it a little easier to factor the trinomial and get our critical numbers. Okay, what adds to or multiplies to -6 and adds to 1 is going to be +3 and -2. We're going to set each factor equal to 0 and get t equals 2 and t equals -3. But we're not going to concern ourselves with negative time. So the answer is going to be t equals 2. At time t equals 2, the particle is at rest. Okay, F, at what time does the particle change directions? Okay, it changes directions, obviously, after it has come to rest, right? Possibly, okay? So you have to check that. It comes to rest at time t equals 2. We need to check that. You could do a sign table or just a number line, okay? But this is F prime, or I should say V prime, okay? So we're going to plug a number to the left of 2 into our derivative. And when we plug 0 in, we're going to get -36. And we're going to plug a number to the right of 2. When we plug 3 in, we're definitely going to get a positive, because that's going to be positive. That's going to be positive. Times a 6 is positive. So we did change signs. Okay. Therefore, we changed directions. Okay. So when V of t changes signs, and that's at t equals 2. All right, I'm going to ask you guys a question on this last one. And the last question is, when is the particle furthest to the right in the interval 1 to 3? Okay. What do you think they're asking for when they're asking furthest to the right?
Greatest positive number.
Okay. So when you think greatest, as far as the things we have talked about in this calculus class so far, okay, greatest is going to be what? What's the term that we have used?
The
Maximum.
maximum.
Okay, maximum is correct. More specifically, which maximum?
Relative maximum?
Not relative, but
Absolute.
absolute. But remember, we're only in this small interval, right? So it is an absolute, or it is a relative in this, but when we're just talking a closed interval, and that's kind of your key right there, is we have a closed interval, we're talking about an absolute max or min, right? If it said to the left, it'd be an absolute min. If it says to the right, it's going to be an absolute max. Okay. So we're looking for an absolute max, which means EVT. Okay. EVT says we have an absolute max at our endpoints or any critical number in between. And there's a critical number in between right here. Okay. So we're going to make a table and we're going to check 1, 2, and 3. Here's t, and we're doing x of t. Okay. So we're going back to the position function here. Okay, back to position, and we're going to plug 1 in. So I'm not going to waste your time on that. And I'm just going to tell you, when you plug 1 into the position function, you're going to get 9. When you plug 2 into the position function, you're going to get -4. And when you plug 3 in, you're going to get 13. Okay, it's asking when. So that's a time. Okay, so it's going to be at t equals 3 seconds. The particle, it was a particle, right? Is furthest right. And don't forget, you got to say by EVT. All right, don't worry about the people that had to go out and come back in because of the sound. Don't worry about it. I also recorded it in case you missed something. Not a big deal. Just Do I have any questions on any of this stuff as far as objects in motion and just really doing what we've been doing, like taking derivatives, possibly second derivatives, and just finding values as far as application goes? Any questions?
Can you just show the rest of G?
Yeah, sorry. Okay, just plugging in 1, 2, and 3 into the position function to see when, obviously the furthest right, but just in that interval. And it's either going to be at the endpoints of your closed interval or at any critical number in between. Okay, remember, 2 could have been the furthest right, okay? And then we could have came back left when we got to 3 seconds, okay? Just happened to be that we didn't. All right, as far as moving forward goes, we have our one more test that's going to cover all of chapter 3 here that we're in. Not that that means anything to you as far as because you don't have a book, but we're in chapter 3, and we were going to have a test, and I was going to spread all this stuff out until December 18th, whenever we're going on break, and then when we came back, we were going to review for the exam and then take the exam, obviously. Well, that's changed now. So I'm actually not going to try to spread it out and slow down, but I'm just going to try and keep a normal pace. So our last test is going to be before the break, before Christmas break, several days before that. And then when we get back, we're probably just going to start going into the next 9 weeks, because there's no point in slowing down since we missed some weeks. We can catch back up to the rest of the country as far as anything goes, because we're not taking an exam. We will do a little bit of review just to recap all the things we learned at the beginning for you, but we're going to get going on semester 2 as soon as we can. Like I said, I don't have any other information other than it's canceled. I don't know anything about you guys coming back into the building or not. I know you guys were sent a survey, but it wasn't binding. So I'm not sure how anything's going to play out for the rest of the time. I just know I'm going to keep teaching you calculus every day. So we'll have Zoom meetings every day like always and go from there. Okay. Any questions?
Mr. Masson,
Yes.
when we turn in this homework tomorrow, do you want us to turn in number 1 also, or just?
No, you could just take pictures of 2 and beyond. That'd be
Okay.
fine.
Okay.
Good question. All right. Anything else? All right. Like I said, I will have your quizzes graded hopefully by tomorrow, if not the next day, but I'll get back as soon as I can. And then you'll know your grades from there and moving forward. And like I said, without that exam, for some of you, that may be a great thing, because if you're like A, B, that's great. You're going to end up with an A. You don't even have to worry about that exam. Those that are like in the D range, without that exam, it may have hurt you. But like I said, we don't have one. So it is the average of the 2 grades as far as I know. And we'll go from there. All right. If you have no other questions, have a great day, and I'll see you tomorrow.